Hi, everyone. My name is Jeff Lee. I've been with the company for a little over 2 years. In my role as a sales engineer, I'm in the front lines engaging with prospects and customers, giving out demos and doing proof of concepts. So I want to give you, my take when it comes to cloud security. So today, I'm going to go over 5 ways that you can improve your security posture. So now let's go over some background and some of the challenges. So here are some statistics about the biggest security threats in the cloud. I don't want to inundate you with these numbers, but rather, of course, let's highlight the largest one, as has been mentioned, numerous times. It's well established that misconfigurations are really the biggest challenge for cloud security teams out there. Most of the time, it's due to simple mistakes. For example, one of the ones that are responsible for, some of the largest breaches out there, S3 encryption is actually enabled by default. So, when you see those headlines where millions of accounts were exposed, someone actually decided to turn it off. So cloud security is often a challenge of ownership, knowledge, and scale. Which team is responsible for cloud security? This issue typically boils down to them adopting a reactive rather than proactive posture. So ownership is not often clear. How do teams bridge the knowledge gap and get up to speed? Understanding a single cloud and all of their security services is already a massive challenge, let alone when you're multi-cloud. And how do you effectively distribute responsibilities and scale them across the teams in your organization? It's very difficult to find, knowledgeable professionals that have prior experience managing complex environments. We often see small teams that are outnumbered supporting hundreds of developers. And currently, companies are now finding themselves in a position where they're transforming their workloads from on-premises to the cloud, where security may seem, foundationally similar, but it requires a different approach. How do you protect something that only runs for a few milliseconds, like a Lambda server? Companies need to start thinking about how they can make their workloads more immutable. So for us, this is where we decide to acquire Secure State a little less than 2 years ago to help customers with those challenges. We want to offer them an advanced security framework to help, not only start some of those difficult discussions, but also help them mature and advance them on their security journey. We begin this cloud maturity framework by encouraging companies to shift left. So as we start moving security into some of those earlier foundational processes, the more ready companies find themselves to face some of those security challenges out there. It typically starts with visibility. People want a way to aggregate their security data from cloud providers with additional context. They want to know what their developers are doing, what type of mistakes they're making. What type of compliance framework should they be adhering to, like CIS, NIST, PCI, or HIPAA? Teams need an easy way to see what they should be following. Then ideally, companies will want to mature to the point that they incorporate automation into their workflows. This includes adding security processes into their CI/CD pipeline, auto remediation, and ultimately shift left. Integrate these security checks directly into the pipeline so everything that they're creating is secure from the beginning. So when I first start talking to prospects, the initial challenge I encounter is usually not technical, actually. It simply starts with understanding who is responsible for the company's cloud security. I'll ask them a question like, who ultimately owns cloud security in your company? Surprisingly, many companies don't have a clear answer to this question. Unsurprisingly, it's because it's a very complicated topic, and it usually spans across multiple teams. Like cloud security is often treated like a live grenade being tossed from team to team until it goes off. So the chart on the left here illustrates this complexity. It can be IT departments, developers, InfoSec, DevOps. Of course, it's not an easy question to answer since it represents many aspects that concern a lot of different teams. So there's often a lot of confusion. On the chart to the right is how companies can begin to solve this question by building a cloud center of excellence. Of course, the implications of a CCOE goes well beyond cloud security, but it definitely helps out. Since cloud security typically concerns so many teams, it can't be solved by any one department. A CCOE bridges this gap by establishing a group made up of representatives from different teams like finance, engineering, security. This is how that critical coordination can happen and a greater plan can be put into action. You can start to address problems like the clarity between teams and what are the roles that they play in regards to cloud security. This is where a purpose-built solution like SecureState can come into play and assist security teams. It's a SaaS platform. We support AWS, Azure, GCP, detects misconfigurations, adherence to compliance frameworks, and helps add security into your CI/CD pipeline. It essentially builds an interconnected cloud security model from your entire cloud inventory. And it adds context, it helps correlate some risks, remediates problems while giving you near real-time insight into your cloud infrastructure. So ultimately, SecureState is that single pane of glass for your cloud security, helping you set up some best practices and gives your developers a central place for API access. So next, let's talk about what you can do differently to help address, let's talk about what we can do next to help address some of those problems. Here are some approaches that I recommend. Hopefully you'll find them helpful. You can start by leveraging your cloud native events. So the first step of many companies is to start with an initial scan of your environment. Then they'll continue with that strategy. But the problem with API polling, it leaves you in a very reactive state. So you're only as good as your last scan. While hackers are constantly scanning for open ports and other vulnerabilities, and of course it can cause hundreds of thousands of dollars worth of damage, and you may not know about that until days, weeks, or months later. Actually, I'm about to start a POC with a prospect that's, although very new to the cloud, but was relying on annual scans previously and was planning to transfer that type of strategy onto their cloud security. Granted, this was in regards to a general security audit, but it kind of illustrates how you have to change your mindset when it comes to the cloud. So SecureState aggregates these event streams from different places, like AWS CloudTrail logs, Azure Activity Logs, and Google Cloud Logging API to give you that near real-time monitoring on new threats and misconfigurations. So next, let's take a look about how important context is and explore an example use case. So security teams are often in a bubble outside looking into what developers are doing, as they're deploying resources into the cloud. Security might see thousands of different violations, and this is where context will help out greatly. Here you'll see there are two different findings on the same SSH port violation. So in the field, I oftentimes have to guide prospects on how to best prioritize their time. Typically, it boils down to spotting problems and how to best address them. So in this case, which one should they prioritize and which one should they fix? So this is where context is extremely important. So the finding on the left illustrates a higher priority than the right because that security group actually has an instance attached to it, while finding number two represents a lower risk because it's empty, and essentially it's something that you can probably fix later on, even though technically both are violations. So having this type of context will help drive down the number of immediate high priority cases, trying to lead you to a more feasible strategy for remediation. So let's take another look at another context example. So here we have another SSH violation. So there are a number of instances that are attached to the same SSH key pair. One of them has an admin role attached. I mean, this by itself is not usually an issue, but again, context matters. So let's say, for example, what if a developer uses that same key and essentially creates a number of new instances which have other internet gateways attached? This could potentially increase the house of cards that you're unintentionally building right now. Someone could use like a brute force technique to get in through one of those internet gateways and eventually gain admin access to that account. So having this type of contextual mapping for each violation can help you not only uncover potential security risks, but also help you in seeing or even showing the issue to other team members like developers. So next, let's talk about how we can enable developers. With all the teams that I come in contact with, it's not uncommon that they're siloed from each other, particularly the ones that would use something like Secure State. So they lean heavily on developers to make those changes and to fix problems. So we're built using an API first methodology, and we want to enable developers by giving them easy API access. This is so that they can accomplish what needs to be done without needing access to the platform. That is not uncommon that developers want to avoid learning another GUI for another tool. For example, they can run security checks on resources as they move them from testing or development into production. Or maybe a compliance and security team wants to check on what policies they're running in the cloud. So naturally, we would come to remediation. So in talking to customers that we encountered, so we ran into an interesting situation. How do we offer auto remediation without ceding control? So most developers don't want to give write access to security. What happens if security makes a mistake? It's not unreasonable. So also, how do we incorporate remediation into the DevOps pipeline? The ideal state for most companies would be to shift left and integrate everything into a DevOps pipeline, but realistically, most of them aren't there today. So the solution we came up with isolates the SaaS monitoring portion from the remediation worker. So the monitoring portion only requires read-only writes, while the remediation involves creating a worker that's contained in a Docker image where you would install behind your firewall. This worker would be under your control only and be given rights access, per account or wherever you want auto remediation to occur. It'll have a list of jobs that you can issue to fix problems such as S3 encryption or deleting empty security groups. So these jobs are essentially Python scripts that we're looking to develop and release regularly to continually bolster the worker's abilities. And the last area I'm going to cover is how to query your inventory through the Explore mode. So although misconfigurations are typically the largest concern, one of the most common day-to-day tasks from users is asking questions about their environment. What instances are attached to this key pair? Which security rules are connected to this security group? So the Explore mode enables users a topographical map of their inventory. So think of it like a search engine through which users can ask questions about their cloud inventory that exists in their cloud environment today. So I'll close by saying that I hope you find these tips to be helpful. Although we were looking through the lens of Secure State, a majority of it can be done through other tools of cloud native services, and it still represents some of the best practices that you can establish on day one. So thank you for your time.